is not next Monday, but the following Monday when we're going to be able to find out what our classwork is.
I don't know. I don't know when the grades are like officially to be in. Okay. This hopefully is like more a review of implicit differentiation than it is like new material. We'll see. So they're going to give you an equation that requires implicit differentiation to take the derivative of. So it's going to have x's and y's in it. And then they're going to ask, like, is the function increasing or decreasing, concave up, concave down, relative max, relative min, which we've done all that stuff. We just haven't done it with implicit differentiation. But it's not really that much more difficult. Like the main idea is, okay, what level do I have to be at to determine if the curve is increasing or decreasing? The derivative level. Remember the original tells you like asymptotes. Basically that's it. Derivative tells you increasing, decreasing. What else? Relative max, relative min. Second derivative tells you concave up, concave down, and points of inflection. So increasing or decreasing, I just need to get to the derivative level. Remember when I'm taking the derivative here, that's got x's and y's in it. So when I multiply, or when I take the derivative of a y, I multiply by dy dx. The derivative of 3x to the third is just 9x squared. The derivative of 3 is nothing. And then I've got a chain rule piece here with a y in it. So your big guy's ln, your little guy's 4y squared. The derivative of ln of whatever is 1 over the whatever. That's supposed to be a times the derivative of the whatever, that's like your chain rule piece, times, I took the derivative of a thing with a y, so times dy dx. So that's the derivative. My job right now is to figure out if dy dx is positive or negative. If dy dx is positive, what's the original function doing? Increasing. If dy dx is negative, the original function is decreasing. So some people I'll see will like try to simplify all that stuff algebraically first and plug in numbers. And I see more mistakes that way than people that plug in the numbers first and work with that. Like I think most of us, it's easier to work with numbers than letters. Is the idea I'm trying to get to. So I'm not going to simplify it. I'm just going to plug in everything right now. So 9 times negative 1 squared. 1 over 4 times y is a half squared times 8 times y is a half. And then that dy dx is what I'm trying to get by itself. It's just, I think for most people, easier in this form than it is with letters. Let's start here. What's a half squared? 1/4, and then 4 times a fourth is 1. 1 divided by 1 is 1. So this is all just useless. So really we have 9 equals 4 times dy dx. Right? Because negative 1 squared is just 1. So dy dx equals 9/4. I care what the number is because like that's a point on your test. You got to get the answer. But as far as increasing or decreasing, all I care about is whether it's positive or negative. That's a positive number. So at the point blah blah blah, is the curve increasing or decreasing? Increasing. And if you had to justify, you would say because dy dx is greater than 0. Question on that? Can I erase or not? Let's still write. Alright, let's look at 2. So now they're asking about concave up and concave down. So what level do we need to get to now? Second derivative, because that's concavity. So again, I've got x's and y's here. So I need to use implicit differentiation. So the derivative of x squared is 2x. The derivative of negative 3 is nothing. What's the derivative of e to the y? E to the y. But I took the derivative of a y, so I'm going to multiply it by dy dx. So to solve that for dy dx, it's going to be 2x over e to the y. Yeah, so far so good. So now I got to take the derivative of that, but that's going to require quotient rule. So I've got to do fig minus gif. So fig f prime is 2, and then good is e to the y. Good. Gif, so g prime. G prime is e to the y, but you took the derivative of a y, so multiply by dy dx. Good. And then it's just 2x. All over. The bottom squared. So now, what I care about is so this is d2y over dx2. The second derivative. What I care about is whether the second derivative, that right there, is positive or negative. So I could simplify. I could even get like real crazy, and instead of putting this dy dx here, I could put this and like simplify the algebra, but I'm not going to. I'm going to figure out what this comes out to. So what is dy dx at negative 2 comma 0? 2 times negative 2 over e to the 0. E to the 0 is 1, so dy dx is negative 4. So instead of that dy dx there, I'm going to put negative 4. Not all that. It's way easier to work with numbers. Whenever you can work with numbers, I recommend that. And then I'm going to plug in everything else that I know and see whether it comes out positive or negative. So 2 times e to the 0 minus e to the 0. dy dx is negative 4. 2 times negative 2. I don't really need to worry about the bottom because anything squared is going to be positive. Just for the sake of like completion, I'm going to put it there. So 2 times e to the 0 is 2. Negative 4 times negative 4 is 16. Times 1 is 16, so this is 2 minus 16 on top. Anything to the 0 is 1. 1 squared is 1. So that's a negative 14. I don't really care that much about the number. I just care if it's positive or negative. Question on what I'm doing? So the second derivative is negative, which means the original function is concave down. If you were asked to justify it, which you very well could be, you would say since the second derivative is less than 0. Question on 2. All right, let's look at 3. Can I erase this or not? Andrew, you still there? So that was how do you find increasing, decreasing, how do you find concave. This one is how do you find relative max. We can do it without plugging in. Plugging in a number line gets a little goofy when you have 2 variables. So this is the original. This is the derivative. And then this down here is my second derivative. So at the point 0, 1, is there a relative max, relative min, or neither? So let's look at what we're looking for first. So relative max, f prime, if I'm looking for a relative max, what would f prime be? So at the top of a hill, what's your derivative? It's going to be 0. So I want f prime to be 0. And I want what to be true about f double prime? That's a relative max. So picture. concave down. So if it's a relative max, you're at the top of a hill, and that whole hill is concave down, right? So you want the second derivative to be less than 0. If it's a relative min, I still want the derivative to be 0. Because you're looking at like the point right here where it turns around. But now if it's a relative min, because I've got this bowl and I'm at the bottom of it, the second derivative would be positive because that shape is concave up. So if it's going to be a relative max, both of these things have to be true. If it's a relative min, both of these things have to be true. So in either case, that has to be true. So that's our first check. Like, does the derivative equal 0 when I plug in the points they give us? So here's my derivative. dy dx equals 2 times the x value, which is 0. And we're good already. So I get 0 over 2, which is 0. So like, that's checked off. So now what do I have to check? Check the second derivative. If the second derivative comes out positive, that'll mean that we're concave up. And that point's a relative min. If the second derivative comes out negative, that means we're concave down, and we've got a max. So we're plugging in x and y again. Just do it to the second derivative now. 2 over 3 times minus 24, 0 squared, 1. So that's 1 minus 0, I believe. 2 over 2 is 1, and then this is all 0 because of that. So the second derivative is 1. So what do we know about the original function? What's that tell us about the original function? Concave up, because my second derivative is positive. And if we're concave up, does that point where the slope is 0 create is it a relative max or relative min? It's going to be min because you're at the bottom of the U. So you would say relative min, and if it asks you to justify, which it does, you would say f prime. I'll probably do it like this. dy of dx equals 0, and then the second derivative is greater than 0. And that's your justification. So that's going through like kind of all 3 types that you'll see. Can you find where it's increasing, decreasing? Can you find where concave up, concave down, and then can you find relative maximum? So there's that homework, which I haven't looked at yet to see if there's any to skip. And then I'll pass out a review. I know some of you guys will want to start over the weekends. Some of you won't, but that's fine too. Don't worry about 70. That's 70. It's not that much. 70. If you find it for number 70, you can skip that one. Only
I think we're asking about number 72.
Oh, yeah.
Oh, right. We can skip that. If you go to your book, you guys shut up. You haven't stopped talking. I've been up here. I'm like, oh, they're surely going to finish up in a second, but no. If you go to your book to 512, there's like a kind of a note summary for you. It's kind of nice. It might not be like the exact way you think about things, but It's just a nice like summary of what we've done in the unit. I thought they don't. Why'd they do it now? But no. It would be nice. What would help you more is if you made your own. So work on that. I'm gonna hand out the review. Oh yeah, and Monday I'll page through the chapter with you. Like, okay, everyone go to 5.1. This section you should really focus on. This part don't worry about so much. So we're back to like this is important. This is not that. So I'm gonna like tell you what to focus your studies on. The test Wednesday. You are not going to be allowed a cheat sheet. I'm debating between no card and nothing.